For this video, we'll be talking about Newton-Raphson method and the Gauss-Seidel method. For the first part, we will be talking about Newton-Raphson method. So for this method, we have the iterative formula x nu is equal to x old minus f of x over f prime of x. So let's go to an example. Given this function, negative 3x cubed plus 25x squared plus 14x minus 16 minus 10x raised to 4 minus x raised to 5. We will first do incremental search method. So this incremental search method is used to find where the function will change sign or the polarity given a value of x. So I used negative 10 and positive 10 for the incremental search method. So we can observe that the polarity changes at negative 10 and negative 9 or 0 and 1 or 1 and 2. So with this, I used negative 10 as the initial x nu. So using this formula, x nu is equal to x old minus f of x over f prime of x. X sub 0 is negative 10. So the function with respect to the function of f of x using the value of x as negative 10 using this equation, we will obtain this value 5344. The function of x, the function of the derivative of x when x equals negative 10, since the derivative of the original function is negative 9x squared plus 50x plus 14 minus 40x cubed minus 5x raised to 4, and substituting negative 10 in the f prime of x, we will obtain this value. So using this formula, x old minus f of x over f prime of x, we will obtain this value here, in which x sub 0 is the x old, f of x is the f of x sub 0 over f prime of x, which f prime of x is our f prime of x sub 0. So we can obtain this value. So the function with respect to x1 using this negative 9.53065167775 in this value, in this equation, we'll get this value. So this x1 will be transferred here in the x sub 0, the x nu. And then the process repeats again, and we can obtain a new value of x1 and a new value of f of x1. So the goal here is to reduce the value of x1 such that the total absolute error is less than 0.0001. So the difference of this f of x1 and this f of x1 should be less than that value. And once it reached that value, the corresponding x1 of that function will be the root of the equation. So when repeated continuously, it will terminate at this value. So this would be the root of this function, negative 9.418439317, because the total absolute error is less than 0.0001. So that is for the Newton-Raphson method. For the Gauss-Seidel method, we have this iterative formula. But before we do that, we need to arrange the equation in such a way that it will be diagonally dominant. Because Gauss-Seidel method is used in determining the roots of 3 equations and 3 unknowns. Diagonally dominant means that A1 in the 3 equations, 3 unknowns should be greater than the sum of B1 plus C1. And take note, all of these are the absolute values. B2 should be greater than the sum of A2 and C2. And C3 should be greater than the sum of B3 and A3. And the total absolute error will be defined by this function, by this equation. So I will discuss this equation in the example. So given these three equations, three unknowns, we will first arrange it in such a way that it would be a diagonally dominant function. So recalling, a1 should be greater than b1 plus c1. So we need to find the equation that a1 should be greater than b1 plus c1. So is 13 greater than 7 plus 28? So it is not greater than 7 plus 28. So we need to find a1. And let's check the second equation. 23 should be greater than 8 plus 9. So this is true. So this will be our first equation here. It will be placed in the first line. For the second equation, b2 should be greater than a2 plus c2. So we need to find b2. So this is b2. 33 should be greater than 23 plus 2. So this is true. And this will be inserted in the second line here. So for the last equation, it will be inserted in the third line. So 28 here, C3. C3 must be greater than B3 plus A3. So 28 should be greater than 7 plus 13. So this is true. So this is the diagonally dominant function. So with this, it is defined that A1 must be in the first equation, B2 must be in the second equation, and C3 must be in the third equation. So in the first equation, we can get x1. So this would be the value of x1. 45 minus 8x2 plus 9x3 over 23, it will be the x1. For x2, we'll find x2 here. So it will be negative 50 minus 2x1 minus 23x3 over 33. That will be our x2. And for the last equation, x3, so 38 minus 13x1 minus 28 minus 7x2 pala. Sorry. Minus 7x2 over 28 equals our x3. So this will be our iterative formula. Using an initial value of 0, 0, 0 for x1, x2, and x3, it will be substituted to the value of x here in the iterative formula. So by substituting, we will get 1.9565, 1.6337, and 0.8572. Negative numbers means that it is a red font means that it is a negative number. So negative 1.6337. So it is this value of x1, x2, and x3 will be then substituted to this iterative formula, like the process that has been done in the first part. So after getting the x1, x2, and x3 here and substituting it in the formula, we will get this following values, the corresponding values. So to determine the total absolute error, d minus e plus the total absolute error is the absolute value of d minus e plus f minus x plus y minus m. D minus e is defined to be like this. This will be the first d and this will be the e. D minus e. This is f minus x. So f minus x, f minus x. And the last is y minus m. Y minus m. So the total absolute error is d minus e plus f minus x plus y minus m. So it should be less than 0.00001 to determine the root. So the operation continues and the iteration continues until that the total absolute error is less than 0.00001. And Once that happens, the corresponding values of x1, x2, and x3 will be the root of the equation, three equations and three unknowns. So this will be the root of the three equations and three unknowns.